Mass and properties today. That is a cat. He is made of matter. He also has a property that he can be kind of persnickety when he wants to be. He's also got a property that he's brown and stripy. Okay, so earlier I defined matter as anything which has mass and occupies space. And your book kind of does this roundabout thing where they don't tell you what mass is until after they use it in a definition. Mass is the amount of matter in an object. Namely, how many atoms or how many molecules are in an object. So what the heck is an atom? It is the simplest unit of any element. Okay, and again, none of these things are all circular definitions because we haven't defined an element yet. We're going to do that pretty soon. You can have atoms and you can have molecules. Okay, molecules are two or more atoms bonded together. Get my hand out of the way in a sec. Two or more atoms bonded together. So these two are connected. One of something, more than one of something. So what's an element? Defined up here. You're going to see elements on the periodic table. You guys are familiar with lots of them. Carbon, oxygen, neon, lead, copper, gold. And it is a substance with only one kind of atom. So again, roundabout definitions. Substance with only one kind of atom. And a compound is related to an element in much the same way an atom is related to a molecule. And a compound is two or more elements bonded together. Okay, that's us together. So we've got atoms and molecules, a single thing, and multiple elements are a single kind of atom, and that's multiple kinds of atoms. Earlier I discussed the cat. I said the cat was brown and had stripes. And what I was doing was using physical properties to define cats. And we use properties to identify substances. Okay, properties identify substances. So you can have a variety of ways to break properties apart. The first way your book does it is they talk about intensive and extensive properties. Now, these I think are easiest to remember with their prefixes. Intensive properties are independent of mass. They're independent of how much of something there is. So an intensive property might be color, or temperature, or fuzziness, or smoothness, or density, or, I don't know. I just ran out. Extensive properties are the opposite. Instead of being intensive independent of mass, extensive properties are dependent upon mass. Dependent upon mass. So those are things like weight, length, the volume of something. All depends on how much of it you have. And then they break properties down into physical or chemical properties, and then we go farther and talk about physical or chemical changes. So we're staying with properties. So this was one way of defining things. The other are physical properties versus chemical properties. Physical properties are properties that can be observed without changing the matter. Whoops, sorry about that. Observed without changing the, let's say, the substance, the matter that you're looking at. They are things like color, length, density. When you measure these things or observe these things, it doesn't change. So when I said the cat was brown and had stripes, those were physical properties. Chemical properties can only be observed by watching a chemical change. Okay? So it's a property which is only observed when a substance changes. Now, you can know something has a property, but you can't be absolutely certain until it changes. So something like the ability to rust or oxidize, is a chemical property. Iron can rust, gold does not. The ability to burn. Wood burns, gold does not burn. Okay? And lastly, we talk about physical versus chemical changes, and that's it for today. So, changes. Another way to identify things, the changes they can undergo. They're also categorized as physical versus chemical. Physical changes are changes that do not result in a new substance. Now, your book has much longer definitions for these things, but these are just working definitions. It's something you can remember. It's not a whole bunch of words strung together to make a complete sentence, just a quick phrase that hopefully will jog your memory. So you're not seeing a change in substance. So for instance, if you saw ice melt and turn into water, it started as water, it ends up as water, it went from a solid phase it went from solid water to liquid water, but it's still water. You can tear a piece of paper. Tearing or cutting. In any case, whatever you have torn or cut is the same substance, it's just in smaller pieces. Chemical changes change the identity of a substance. I'm just writing down ID because it's shorter. So up here we had burning. The ability to burn is a chemical property. So if something does in fact burn, that is a chemical change. Wood and wood ash are not the same thing. Cooking, lots of chemical changes. Okay, a raw egg is not the same as a cold egg, a raw egg is not the same as a cooked egg. Its properties have changed. You're not going to get the raw egg back again, just like you're not going to get the tree back from the ash. So that's it for today. We already had matter, and we've got mass, which should have been defined before matter, but it wasn't. That's your book, not me. Atoms and molecules, and those two are related. Elements and compounds, those two are related, and then properties are used to identify substances. And you can have two categories of properties, intensive or extensive, or physical or chemical. That's it for today.